Hello everyone and welcome to Bell Explains. In this video, I will be explaining Chapter 2, Factors, Prime Factors and Highest Common Factors. Determine whether each of the following numbers is a factor of the number in the brackets. So a factor is a number that can divide another number into a whole number. So here we have 12 in a bracket that is 40. So they're asking whether 12 is a factor of 40. So let's try and put it into our calculators whether 40 can be divided by 12. And that answer is no, because we do not get a whole number. Next, for B, let's take 50 divided by 5. So since we get a whole number, it is a factor. So 5 is a factor of 50. Next, 24 divided by 8, and we get a whole number, which means 8 is a factor of 24. 90 divided by 6, so that is a factor. 45 divided by 3, we get a whole number, which means 3 is a factor. 56 divided by 14, and we get a whole number as well. For G, 60 divided by 15, and we also get a whole number. And lastly, for H, 98 divided by 18, and we do not get a whole number, we get a decimal, so that is not a factor. Next, for number 2, list all the factors of each of the following numbers. So let's try it out here. Let's see what numbers can divide 15 into a whole number. So if we divide 15 by 1, we get a whole number. If we divide 15 by 2, we will not get a whole number. So let's try 3. We get a whole number. 4, we don't. 5, yes. So we go on and keep looking for a number that can divide 15. Next, for 2.1, determine whether 3, 5, and 7 are prime numbers of 30. So what are prime numbers firstly? Prime numbers is a number that cannot be divided by any number except for 1 and itself. So let's see if these numbers here are prime numbers first. So 3, can it be divided by any number other than itself? So 3 divided by 1, we get 3. 3 divided by 3, we get 1. So other than that, there is no other number that can divide 3, which means 3 is a prime number. All of these numbers are prime numbers here except for 9. 9 is not a prime number. So 3 is a prime number and it is a factor of 30. 5 can divide 30, so it is a prime factor. However, 7 cannot divide 30. It will not give us a whole number, so it is not a prime factor of 30. For B, we have 3, 5, and 9 are prime factors of 54. 3 can divide 54, so it is a prime factor of 54. However, 5 cannot divide 54. It is not a factor. It will not give us a whole number. And as for 9, it is not even a prime number, so it is impossible to become a prime factor. Next, for number 2, we have list all the prime factors of each of the following numbers. So for 36, let's see, let's list it down first. All the factors of 36 are 1, 2, 3, 4, 6, 9, 12, and 36. However, not all of these numbers are prime factors. Only 2 and 3 are prime factors in this list because all the other numbers can be divided by another number. Next, for 48, let's list down the factors. We have 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. So here the prime factors are 2 and 3. Next, for C, 58, we'll list it down. We have 1, 2, 29, and 58. However, the only prime factors here are 2 and 29. And lastly, for D, 99, we have factors 1, 3, 9, 11, 33, and 99. However, the only factors here are 3 and 11, the only prime factors here. Next, for number 3, express each of the following numbers in the form of prime factorization. Okay, so for A, we have 42. Let's do a factorization. We have divided by 2 here. So that will give us 21. Then divided by 3. That will give us 7. And then divided by 7. That will give us 1. So here we have 2 times 3 times 7, which will give us 42. Next, for self-practice 2.1c, determine whether each of the following numbers is a common factor of the list of numbers in the brackets. Okay, so we'll see whether 6 can divide all of these numbers in the brackets. Can 12 be divided by 6? Yes. 24? Yes. And 42? Yes. So 6 is a factor of these numbers in the brackets. For B, we have 8 divided by 8. Okay. 32 divided by 8, yes, and 72 divided by 8, yes. So yes. For C, we have 12 divided by 3, yes. 18 divided by 3, yes, and 20 divided by 3 will not give us a whole number, so it is not a factor. So this is a no. For D, we have 48 divided by 12, yes. 96 divided by 12, yes, yes, and yes. So this is 12 is a factor of these numbers. For E, we have 28 divided by 7, 35 divided by 7, 91 divided by 7, yes, and yes. So this is a factor. 7 is a factor of these numbers. List all the common factors of each of the following lists of numbers. So for A, for 12 and 30, we have 1, 2, 3, and 6. For B, we have 1, 2, 3, 4, 6, 8, 12, and 24. So don't be confused. You just have to list down the numbers that can divide these two numbers. Next, for C, 35 and 105. So the common factors here are 1, 5, 7, and 35. For D, we have 12, 84, and 98. So the numbers here are 1 and 2. By using a suitable method, find the highest common factor of each of the following list of numbers. So let's do factorization here. We have 24 and 48. So 1 and 3 cannot be divided by any common number, which means this will be it. That's all we have here. So 2 times 2 times 2 times 3. And that will give us 24. So 24 is the highest common factor here. Next for B, we have 18 and 54. So here let's do the same thing. We have 9 here, 2 and 6. Once again, 1 and 3 cannot be divided. So 9 and 2 gives us 18. For C, we have 36 and 96. Here we can divide it by 3. That will give us 12 and 32. So dividing this again by 4 will give us 3 and 8. But these two numbers cannot be divided by a common number. So we'll have 3 times 4. That will give us 12. For D, we have 30 and 72. So here dividing it by 3, we have 10 and 24. Dividing this again by 2 gives us 5 and 6. But 5 and 6 cannot be divided furthermore. So here we have 3 times 2. And that will give us 6. For E, we have 36, 90 and 108. So here dividing it by a common factor, we have 9 here. That will give us 4, 10 and 12. So dividing it further, we'll have 2 here. That will give us 2, 5 and 6. But these numbers cannot be divided by a common number. So we have 9 and 2. That will give us 18. Next for F, we have 42, 54 and 84. So dividing this by 2 gives us 21, 27 and 42. So these numbers can be divided by 3 again. That will be 7, 9 and 14. So 2 times 3 gives us 6. Next for G, we have 140, 256 and 348. So dividing all these numbers by 4, we have 10, 64 and 87. So these numbers cannot be divided by a common factor, which means the highest factor here is 4. And lastly for H, we have 27, 45 and 60. So here we can divide this number by 3. That will give us 9, 15 and 20. So since these numbers cannot be divided by any other number, that will give us the highest factor of 3. Next for 2.1e, the police cadets in a school donated 60 sacks of rice, 78 bottles of cooking oil and 90 bottles of mineral water to some flood victims in a district. All the things were divided equally in each box for the flood victims. What would be the maximum number of boxes that were prepared? So here we will have to find the highest common multiple. So we will have 60, 78 and 90. We'll start by dividing it with 2. We have 3 here, 39 and 45. So these numbers can be divided by 3 again. So we have 1, 13 and 15. These numbers cannot be divided anymore, which means we have 2 and 3, so 6. Next, at a Hari Raya party, Mak Mina prepared 45 pieces of kueh kochi, 75 pieces of kueh taco and 90 pieces of curry puffs. She wished to serve all the food on same plates. What would be the maximum number of plates needed if all the food was distributed equally on all the plates? Okay, so we'll do the same thing like just now, 45, 75 and 90. Here we will divide it by 3. We get 15, 25 and 30. So dividing it by 5 again, we get 3, 5 and 6, and that cannot be divided anymore. So we have 5 and 3. So that would be 15 plates. Moving on to Mastery Q 2.1. Find the greatest number that is a factor of both 45 and 75. So here we have 45 and 75. The common factors are 1, 3, 5 and 15, which means the highest number, which is a factor, is 15. Next, for number 2, write the prime factorizations of 1968 and 4968. So let's do that here. Dividing this by 2 again will give us 492. Dividing it by 2 again, we have 246, then 123. And this cannot be divided by 2, so we'll divide it by 3 and we'll get 41. So 41 cannot be divided by any number. So we'll have 2 by 2, 2 and 2, 3 and 41. So for 4968, we have divided by 2 again. So we'll have 2484. 1242 again, by dividing it by 2 gives us 621. So the common factors between this number and this number here is up until number 3 here. As you can see, both of these factors come out until here. After that, it is not the same anymore. So the highest common factor between 1968 and 4968 is 2 times 2 times 2 times 2 and times 3. So that will give us an answer of 24. Next, the highest common factor of n and 36 is 4. If n is less than 36, what are the possible values of n? So let's state all the numbers here. We have 4, 8, 12, 16, 20, 24, 28 and 32. However, the number cannot be in the multiple of 36 because then the factor will become 3. It won't be 4. So we'll have to remove this and this. So all of these numbers are possibly n. Next, for number 4. 3 pieces of string have a length of 192 cm, 242 cm and 328 cm respectively. Aisha wishes to cut the strings so that every piece is cut into the same number of segments with no extra string left. What would be the maximum number of segments that each piece of string can be cut into? So here we have 192, 242 and 328. We'll do multiple division again. So here we'll divide it by 2, 96 here, 121 and 168. So these numbers cannot be divided again, which means we only have 2. And lastly, for number 5, Anita wishes to cut a piece of paper measuring 260 cm in length and 20 cm in width into several square pieces. What would be the measurement of the square pieces so that there is no paper left? So here we have 260 and 20. We'll divide it by 2 first. That will give us 130 and 10. And we can divide it by 10. That will give us 13 and 1. So here we have 2 times 10. That will give us 20.